In this video, we're going to step through the inputs for the user specified release. I need to, or don't need to, but the easiest way to show it is to bring up the description dialog input. And here, we've already seen this in a couple other videos, but you will change from container surface description to user specified. User specified after release conditions is probably the second most used release type in CHARM. In the container surface description, you provide CHARM with information that's just at or prior to release, and then CHARM will calculate the source term, in other words, emission rate, temperatures, mass fraction of droplets, etc. In user specified, it assumes that you've already done those calculations, so you have an emission rate, you know what the mass fraction is of droplets, and so it's a different mindset in the fact that this is right after the release has begun, so you have to give it an exit temperature, for instance, rather than a storage temperature. Other than going with the release type change on this first screen, the basic screen, it's identical to the container surface description. Same thing with location. This screen is identical. So we'll go into the emission rate screen, and here you can have three basic kinds of release, and one is instantaneous, just a certain amount of mass that's released instantly. So you have various units for mass, but it is mass. Second is a continuous release, but the continuous release can vary, either linear decay or a constant or an exponential decay. And when it's an exponential decay, it uses the number you provide at the bottom here for duration to figure out at duration. I believe it assumes the release rate is like 1% of the initial emission rate. But duration is actually used for all the emissions. It's just when the emission stops. And third is a user specified. Well, let's go to the instantaneous. Yes, and see, it made a liar of me already that you can enter in feet, cubic meters, or mass. So it's volume or mass, but then on another screen, there's going to be a question about whether the material coming out is liquid or vapor, and depending on what you answer there, it will calculate a mass from the volume. Otherwise, it uses the mass straight away. Let's go to user specified, where you enter in a time schedule. Now, this is a new screen in the fact that the temperature, exit temperature in the schedule is, you can enter that as well. Used to be up until just recently, the temperature was not there. It was assuming that the temperature was from, if you would give a emission rate and it would calculate a temperature difference if, well, at any rate, you can enter in the temperature directly here. In previous versions, it's almost always the boiling point of the liquid or ambient, whichever happens to be lower. Some of the things you can do with the user specified schedule here is, if you are in a container surface description, one of the options is you can look at the output from the container, and that you can copy into the clipboard, and then you can paste it. This button would be available then, and you can paste the data directly into the user specified schedule and modify it. Or you can have an Excel spreadsheet, create the table, and then select it, copy it, and paste it. Let's go back to continuous, and we'll move to the next tab, which is particles. Same kind of discussion as for the container surface description. If there are particles, then you have the option of either giving it a size distribution or not. And if you do the size distribution, the mass of the emission is spread out over the particle size distribution according to the size distribution. Otherwise, a mono size particle calculation is done, and they're evaporated or condensed. So usually most new users don't use particles, at least for a while, until they absolutely need it. It does add a lot to the calculation time. Next is exit description, and so this is where the emission enters the atmosphere. So you need the height above ground where it's actually entering the atmosphere, and you also need to know the source diameter of the area. And this is source diameter or area. This is the diameter or area of it entering the atmosphere. CHARM will do a expansion calculation for you. So this is actually where it enters the atmosphere. And exit temperature, as I said, if nothing else is given, it assumes that it's the lower of ambient or boiling point of the material. And of course, you can always enter it. Now, if you enter it here, then it's a constant value throughout the release. Next is velocity. As you're exiting wherever your source is, because keep in mind, CHARM at this point does not know that this is from a container or however what's happening just before it enters the atmosphere. So similarly to the container surface description, the horizontal direction is required, and the default is that it's going to go along with the wind to minimize mixing and maximize downwind concentrations. And this release angle, if you remember in the container surface description, or if you've been there or not, the container surface description, the assumption is the release angle is 0, which means it goes straight out horizontally. And in the user specified, most of the time that CHARM has been used for user specified, it's been stack releases. So the default is that it's a 90-degree upward pointing vent. But you can change it anywhere from 90 down to minus 90 going straight down. You can have CHARM calculate an exit speed for you, or you can enter it in directly. And on this screen also is that indication of whether this comes out as a vapor or as a liquid, and that can be used in the instantaneous release. If you give a volume, it will use either the density of the vapor form of that species or the liquid. Next tab, that's the last one, that's a little different than what was in the user or the container surface description, is you enter in directly droplet mass fraction, molar water vapor fraction, and molar air fraction. You can have CHARM calculate a molar air fraction. For instance, if you know that the material comes out at, let's say it's 90% chemical and 10% air, you can put in the 0.10 for the molar air fraction, and then it will calculate that it's 90% the actual chemical. simple math there, but the molar air fraction is going to have an effect on the exit speed calculation. If you have a lot of air mixed in with the emission rate, the exit speed has to go up to get enough volume of air plus chemical out into the atmosphere. Water vapor fraction, that's almost never known a priori. It's for an emergency release, but it is used in planning and after the fact releases if you have that kind of information, but it's fairly difficult to come by. Droplet mass fraction is, as the name implies, the mass that's coming out, you're specifying what fraction of that mass is in droplet form, and whatever is left over is in vapor form. And then JARM will calculate the two together in the emission. The final screen is the nuclide selection, and just like the container surface or any of the releases, you just select the radionuclide that you are interested in, or that is coming out at the release site. For instance, we'll choose one, just show you something slightly different than in the container surface description. If you apply that, then under displays, you can actually ask for a nuclide decay chain, except, oh, well, see, I selected a boring one. Let me get rid of that. Try something completely different. Oh, well, all I'm picking out is boring ones, but there are nuclides you can select that will have, they go down a number of paths of creating daughters and are all used in the calculation of the radiation. At any rate, that's the end of our inputs for the container surface description, although I'll grant you it's pretty fast and just an overview. But that's the end of this video.